So, hello, Samuel. So today on Uncle Data we have a guest, Samuel Colvin, who's spoken at PyCon Lithuania today, and he talked about he gave a keynote on Pydantic, how it went, and covered a lot of things about reasons why rewriting Rust, and gave a demo, how certain things work here and there. So. Thank you for joining me, for agreeing for this, thing. It's first time for me doing this live, so it's gonna be, even a better experience for me. And so, Samuel, I have one question for you: is how did the idea of Pydantic came to life for you? What caused it?
Well, first of all, thank you so much for having me. Really fun to be here. Yeah, I would love to say I had some big vision when I started of what Pydantic was going to become and that it was going to take over my life, but honestly, I didn't. It started off as an experiment in a file, in a project. It was 2017, so type hints were relatively, well, they weren't technically new to the language, but they were in big growth, right? They had come to the fore in Python 3.5, and they were there, but they felt like this weird chocolate teapot where once your data was typed, static typing could go and help you, but if you were reading real world data, it didn't help at all. So in particular, I was trying to read HTTP headers, and it was it fitted into my model perfectly, but there was obviously no validation at all. So I annotated something. This was before data classes. I annotate something with int, and I want it to be an int, but obviously it comes in as a string and nothing complains until I try adding something to it, and then obviously everything fails. So I was like, can I read these annotation things somehow? And it kind of worked, and it went from there.
Okay, and what's with the name? I guess with Pydantic?
Well, yeah, so it came from being pedantic, and obviously Py. The irony, of course, is that Pydantic is not very pedantic, particularly in V1, where we default to coercing data types, often in sensible ways, sometimes in slightly mad ways. It used to be even more lax than it is now. So for performance reasons, the rule to start with was if you want something to be a list, call list on it, and if it works, great, and if it fails, not so great, and you raise an error. But you had situations where, let's say, you had a list of integers, and obviously our technique for converting something to a list was to call list on it, and our technique for calling to get an integer was to call int on it. So if you passed the string 123 to something that was supposed to be a list of ints, you call list on it, you get a list of 3 single element strings, and then you call int on each of them, and you go from the string 123 to the list 1, 2, and 3, which in English sounds right, but in code sounds crazy. So we pulled back on some of that laxness over the course of V1, but particularly since the release of, pre-V2, but particularly after release of V1, we couldn't make breaking changes. So yeah, that's one of the reasons that myself and Eric Julibo, who back last year were the main maintainers, we knew that there was a bunch of stuff we wanted to fix that was going to involve breaking changes. So that's where this idea of what would V2 look like came from.
Okay, and what drove choosing Rust, right? Apart from because there are other strict type languages which are also popular, and have quite a good adoption, in general in the community, programmers.
Yeah. I think that the options, if you're trying to write a Python extension, are C, C++, or Rust. I'm sure that there are ways of calling into other languages. I know, for example, Julia has some interop with Python, but if you're trying to do it in a performant way, really your options are C, C++, or Rust. I am not good enough or not patient enough to be a C developer. I didn't particularly want to become a C developer. C++ and the Boost Python extension I have used in the past, but if you look at the developers of Py03, which is the Rust binding for Python, were the maintainers of Boost before, and they moved towards Rust. I don't know. I had done a bit of Rust before that, and I wanted to learn more. Why did I make the decision? Good question. Was it the right decision? I'm totally confident it was. Rust, I'm more and more of an advocate of. I'm one of those boring rewrite everything in Rust people. Not quite rewrite everything in Rust, but I think it was definitely the right choice for this application.
Okay.
I think the honest answer is either we should have kept it in Python and saved 6 months of my life, or rewritten it in Rust. I don't think there's a good kind of third way.
Okay, that makes sense. So what would you say, were your, let's say, lessons learned, from Rust, right? You mentioned, that the code-wise, it's quite harder to read. It mimics more of a, let's say Java, Scala, and other those languages, right? So what would you say, are the pros and cons, apart from those you mentioned, compared to Python?
I think one of the weirder things that's a pro and a con is that you're forced to think about everything that Python does, right? So let's say you do have some data class and you do my data class dot foobar +4, right? You think of that in Python code, you just see it as one line, you don't even think about what's going on. If you write that out in Rust, you have some object, you do getAttra to then get the attribute foo. You have to catch the error that might not exist. Then you get back a value. You inspect what type it is. Then you append to it. You catch the error or you might catch the error if the types are wrong doing the add or whatever. So you get to all of these steps you've written out make you think about it much more. And so you end up writing Python code where you're much more careful about all of the intermediate steps that Python is taking. If things like getting attributes, all of the different errors that could be raised. That in some ways makes you a better Python developer. There are places where you become probably a worse Python developer because you think too hard about all the different stuff that's going on. You're like, oh, well, that using star args, that means an implicit conversion to a tuple of a list. Oh, I can't do that. That's a conversion. And you can overthink it sometimes, and it can slow you down. But overall, I think it makes you a much more deliberate Python developer. But more generally, in terms of the trade-off, I think that there's obviously Rust code is more verbose. It is less easy to read. There are fewer people who can write it or read it. So you do have to accept that. That can be a strength or a weakness. I think there's Linus Torvalds was asked why he hadn't rewritten the Linux kernel in C++, and he was like, so I don't have to speak to C++ developers. And if you're being really brutal, there are places where having a library where it has a slightly higher threshold to contributing can be helpful. It's probably not a very trendy or correct thing to say in the Python world where we're trying to be accepting, but you do have to accept as an open source developer that a vast number of the contributions you have cost you more in time than they save you. And so there's a trade-off there. It's not easy. It's not a universal win or a universal loss.
Okay, but that actually makes sense, right? Less time than for you to review as a maintainer, right?
What's definitely true is that if someone can submit a PR and it compiles and it passes tests, you can be reasonably confident that a bunch of stuff works. It's a whole load more difficult. Effectively, the Rust compiler does a whole phase of the review process for you that you don't have to go and do.
But that makes sense, right? Since Python is runtime, right?
I have this philosophy, and I had a backup slide in case someone asked a question that I didn't show in my keynote now, but I talked about it in the FOSDEM talk I gave in Brussels back in February. Python is an amazing language. There are lots of things that definitely should be written in Python. I'm not advocating that if you're building a web application, you want to write your business logic in Rust. It would be a complete pain. But it's mad that we have libraries like Pydantic written in Python. They're an obvious candidate to go and be more performant and better in Rust. So I have this, if you think about the lifespan of a request, from when the packet hits your server to when you return a response, right? You have HTTPS termination, encryption termination. That should all be written in C. It already is, thankfully. If it was written in Python, the world wouldn't work, right? Then we have routing. Ideal world, that routing should be written in a compiled language like C or Rust. Then we have our application, then we have validation, maybe with Pydantic, which now will be in Rust. Then we have our application logic where we basically say, we go do a query. So we then pass the query off to the database. That should all be written in C or Rust or whatever to be fast. Then we get back some data. We want to serialize that to JSON. That should not happen in Python. And then we return that to the user, and all of that stuff down the line from the networking, et cetera, should all be written in C or C++ or Rust or whatever. So my theory is that you have 99% of the code of the business logic should be Python, and 1% of the execution time should be Python. And I think that that's the world that we should move towards. So there are more and more libraries that I think are good candidates to be written in these lower level, more performant languages, so that you get the best of both worlds.
Yeah, that's true because it's the easiest language to get in because you don't have to know all the nitty gritties, like how to create like all of the strict typing, think ahead because in Python you can easily go, this is a string, now this is an int, just assign it that one, and in other languages it won't work, but it's a good introduction to general programming, so that actually makes sense. So with the abstractions and whatnot, so I wouldn't say as well, right, both are free, right? I don't think that it should, be rewritten in some cases, for you if you want to interact with S3, for us, right? Because it doesn't make sense. It's already running and it works. So that actually makes sense. Another thing, like what I wanted to ask you is, like, you mentioned in your slides and in your keynote, about the penguins and in general, about energy consumption, right? And Python is one of those languages which actually, is quite consuming a lot, right?
Yep.
So how you think, in the end, or like, like, I don't know, in 5 years' time, right?
Yep.
How many more, of these kind of changes we'll see, that more Python libraries, like mentioned, will migrate to Rust or other languages?
I hope more do. So Polars is a great example. I know you're going to speak to Richie. I'm looking forward to listening to that. I've spoken to him a few times. He's on a similar journey with an incredibly popular library that's growing fast and has had similar discussions, I know, about turning that into a company or whatever. It's an obvious candidate to do in an optimized way. Yeah, it comes back to the like lifespan of a request that I talked about. But you can think of that lifespan as about like any task effectively. It could be like, running a simulation, running a simple query to do some like data science, although it was almost too trivial to be data science, my example, analyzing some data. We can effectively think of Python as the control panel for an engine that's written in other engines that are written in other languages. And that's not to trivialize Python. Python's amazing and it can do really complex stuff, but where performance really matters, it's obviously not the right language. The other thing I think to say is that the faster C Python team, Mark Shannon in particular, is making amazing progress with making Python faster. And so that tide is rising as well, as in Python is getting 10, 20, 30% faster. It's not going to become 100 times faster because it is what it is, but it's happening. The other thing I think I would say is, when you think about the logic that runs when you hit an endpoint or when you run something, yes, some of it is application code, but there's a whole bunch of other stuff that has to happen. So often you have to spin up a container because you're running untrusted code, and so you need to have a container or you need to have a separate VM host, et cetera, et cetera. That's all, some of that's networking, but a lot of that is literally just crunching code, right? And there is one of the other disadvantages of Python is that it can't be sandboxed like JavaScript can, so we don't have the concept of an isolate. So I'm not going to talk about it right now, but there are some exciting things I hope coming from Pydantic, the company, which can help solve some of those problems. Because, yeah, I've talked my very simple description of a request misses out the fact you might have to go spin up a container in the middle of that process, which has got seconds of overhead, seconds of CPU time to do.
Okay. Another question, more to the Rust topic, right? You mentioned that it was quite an interesting journey for you to write it, knowing like how to write this, think a lot of ahead, right? So would you say that, like, how would you treat, or like would you suggest for every Python developer or like person working with Python, to at least learn the basics of Rust?
I don't think you have to know Rust to be a good Python developer. I think I was a perfectly good Python developer 2 years ago, and I had not written much Rust, or 3 years ago. I think that it is a valuable process to go and do it. It's definitely fun. I think yes, it probably does long term make you a better developer, but I definitely don't think it's required. I think it's more important that more people learn Python than that the people who already know Python learn Rust.
Okay.
You can look down the telescope from either end. As a hiring person, I have found it in the past very hard to find people who are good at writing Python, let alone good at writing Rust, which is harder. So let's get some people who are good at Python first. Look at it from the other end of the telescope as an individual. You could go and get a job being paid good money to write Python without any understanding of Rust or C. But as you go on through your career, having some understanding of that stuff probably is valuable and fun.
That's true, right? Because learning more things in how other engines or other frameworks work, right? Usually it boils down into some different language in some case, right? So that gives the T-ship skill, right? And it gives you more like value as a professional as well. Okay, and then my question, it's a bit like going to be a bit provoking. Do you see that Python at some point will become more stricter with the types, or maybe even become at some point a compiled language?
I doubt it in that form. I think that Pydantic, for example, couldn't exist in Rust, right? As in, yes, there's serde, yes, you can go and compile code to do validation, and there are contexts in which that's definitely valuable. But like, Pydantic is able to exist precisely because, like, in the end, everything's an object in Python, and you don't have to ascribe a particular type to it when you define it, and you can change it. So I don't see that happening. I think type hints will become more and more pervasive. I was really interested in hearing, I forget Carl's second name, but Carl, who works at Instagram, talking about Instagram's journey to take their enormous code base and apply types to it. And someone asked, well, what was the pushback? Who didn't want it? And he said not a single developer at Instagram/Facebook didn't want types on a code base of that size. So I understand entirely. I come from a background of not using types. The company I ran before, we didn't have types in our code base. I'm not one of those people who must apply types to every single 3-line script I write. But I think when you get to a big size code base, they're like absolutely transformational. And I think that more and more people will see that in big code bases.
But that's one of the things when I noticed actually, the typing, because when you read lots and lots of through code, it's like, what's this supposed to mean? Usually, when people are like, they don't think through, what they're writing, right? You end up with some, very ambiguous names, and then you have to guess it or like, backtrace it somewhere, what's passing, what's done here and there, and so on. So actually, one of the reasons when I discovered actually typing in general was to make my life easier, because even when you hover on something, all of the stubs and everything helps you easier navigate and understand what's happening. Yeah. That docstrings generation as well adds a bit of help there. So
I was interested. I tweeted a few weeks ago on this exact subject. There was some guy who, I don't know, I forget his name, who was complaining that TypeScript has like made JavaScript worse and that he much prefers JavaScript. I was like, it's definitely a controversial opinion. But I retweeted saying this guy is wrong, but I do think that type hints are like coffee. You should consume them a lot, but you shouldn't get completely reliant on them to the point where you can't survive without them. And the most interesting thing was the number of people who replied being like, I am completely reliant on both type hints and coffee. As in, every single line of code I write, I put types on it. Will, who maintains Rich and Textual, replied being like, I think he said, I'm completely dependent on both. And I'm interested that there is a wave of Python developers who now think you put types on everything. And I'm not one of those people. My examples I showed you today, they obviously use type hints where they're used within Pydantic, but like, I'm not a like type everything. I'm not a like MyPy should pass in strict mode for application code always. It does obviously for Pydantic, but like, I'm not actually, ironically, on the like vanguard of the like everything should be typed world. I think it's super valuable that we can write Python code without them.
This is the same like you mentioned, and not everything has to be rewritten in Rust because it doesn't make sense always, right?
Yeah.
So I guess it's going to be interesting, from my perspective, from data engineering, right? How it will, in general, end up in the data engineering community, because there, I think the biggest player was Spark, right, which is a JVM language, like on JVM build, and then you have schemas, kind of strictness there, but it's kind of loose, if you're not using Scala, and with polars coming into place, right, it kind of makes sense that more and more adoption will come from this, and from what you showed, like inbuilt in polars, Pydantic models, it's already seems, to be a good help, for anyone who's going to be starting there. So I guess that's going to be a fun journey to see, how Pydantic goes and how polars, as I see one of the main contenders, as to dethrone Spark at some point.
Yeah.
With this.
Yeah, I agree. So. Yeah, and we were talking just before we started recording about, like, there are definitely places where you want to store unstructured data, unstructured JSON or whatever else it might be. And that's not going to change, so there's going to be value in tools like Pydantic that let you try and coerce it and give you hopefully helpful errors when it fails. We're not going to move anytime soon to a like everything's typed world. I don't think that even ChatGPT is going to fall over when you tell it to like type in the universe. So I think that like we're going to be dealing with some unstructured data for forevermore.
Yeah, that's true.
And that was the point. That's where Pydantic came from, was that like type hints, static type analysis works when everything has already got a type. When the thing coming into your function is, you already know it's an integer. You know you can add another integer to it, and you know you get an error when you try and add a string to it. But like in many, many contexts, that's not the case, right? You're loading data from the real world where you either don't know the type or the type is not defined as a Python type annotation. And so that's where Pydantic comes in, is that bridge between real world and Python code.
Okay. And I guess the last question from my end is like, what would be your suggestion for people who are actually not yet using or aware of Pydantic?
I mean, go have a play now. Go and install the alpha release of Pydantic v2. There's obviously, I hope this talk will be up on YouTube in time. My talk from PyCon, which is, spoiler alert, quite similar. A few things have changed. Or of course, look, you can go and get started with Pydantic v1 right now, and that's like production grade, used by every FAANG company, by like 19 of the top 25 companies in NASDAQ, by like lots of big companies, right? Like from NASA to JP Morgan to Google, it's being used. So it's production grade now. And if you're doing simple stuff, your code will just work with v2. If you're doing crazy complex stuff and digging into the internals of Pydantic, your code will break. But that's not going to be the case if you're getting started tomorrow.
Yeah, but that you can switch already, from v2, and you're good to go.
Yeah.
Cool. So thanks a lot, and for everyone who came to listen. So thank you, and have a nice day.
Thank you so much.
Thank you. Thank you. Can I still ask questions?
Yeah, I mean, you could definitely ask me
Shoot
questions.
All right. But I have a question just in general because oh, here. Okay. I've seen that you've started a new company and you've also shared that on Pydantic, but it's rather secretive. Maybe you could share what you're trying to do there with the company, and how is it going to impact Pydantic?
I can so the second bit of your question I can answer very simply. It's not going to affect Pydantic, other than that there's a bunch of us who are paid to work on it. And Pydantic's success and its popularity is absolutely like critical to the company's success. So it's going to remain MIT licensed. It's going to continue to be improved, and there's absolutely nothing's going to happen other than that it's going to carry on getting better. In terms of what the company, how we're going to make money, I'm not going to go into that right now. I'll tell you precisely why. We're just getting to the end of, so right now the company, the team, we're 7 people right now. We're working flat out to get Pydantic released. Now/next Monday, I'm starting doing interviews with people to work out whether or not the thing we're thinking of building will be any use. And if the answer is no, then we'll have to pivot and build something else. And so I don't want to constrain what we can do by promising this is the vision for what we're going to go and build. Because honestly, the vision has already changed since I raised the money in speaking to lots of different people. And so I would be, if I had written in the blog post where I announced the company, this is what I'm going to go build, I would now already have to go out and be like, oh, slightly embarrassingly, we've now changed to something else. So I'm not talking about it too much publicly so as to not constrain what we go and build.
Okay. But just to give it a taste, so it's still something in the cloud, because I think you mentioned something.
Yeah. So it will be cloud services, because it's really hard to get people to pay for software directly. And obviously, we're a company, we need to make money. We've got an investment, obviously, and the investors, whilst great and entirely behind the open source, rightly they want to see some income. So yeah, it'll be cloud services for developers. I think probably the most interesting thing to say is Sequoia in particular, who led the round, I don't think they care that much about Pydantic directly as its commercial value. They don't care that much about the 200,000 users we have come to the website each month. What they care about is that they hope I and the team are good at building things developers love. And obviously the marketing PR value of Pydantic has some value in addition, but there's no investor has ever suggested anyone what we commercialize Pydantic in the sense of changing the license. So it's really take the principles that made Pydantic successful and go and build a cloud company off that.
It's pretty exciting.
Yeah.
Any more questions?
Hi, thank you very much for this talk and for an outstanding opening talk as well. My question is, as web developer, mainly web developer, who would really love to live in a dream world and use, for example, such frameworks as Fast API only with Pydantic built in, I'd be really happy about that. But as a web developer living in a real world, unfortunately, I am dealing with projects written in Django, for example, which are like decades old, or at least 5 years or something. They don't have type hints. They are extremely the implementation of Pydantic in such a project is a lot of pain. Would you have some hints
Yep.
for all of us?
Yep. So the first thing to say is Django Ninja, which is a library that available now, which basically allows you to leverage Pydantic within Django today. And I've already spoken to the maintainer of that. He's been very active on the issue tracker with regards to V2 and what he can do and what he can't do. So I'm sure that Django Ninja will upgrade to Pydantic V2 fairly soon. I think it's probably second after Fast API, definitely in the web space in terms of the most starred or most used libraries that depend on Pydantic. So it's already quite big. Quite a lot of people are already using Pydantic within Django. The other thing to say is you're not the only person to have had this pain. In particular, lots of big companies have. So for example, Instagram's app was basically a massive Django app for a long time. I think it's like quite far removed from the traditional Django, but they have a project called Monkey Patch, where basically they monkey patch Python to collect the types of data that are passed to each function, store that in a database, and then you can come along afterwards and effectively apply type hints to existing code using runtime usage. And then once you've done that, there's a second project, the name of which, a few different projects, which basically, so that normally gets you from like 0 to 70% complete types. Once you have 70% complete types, there are other libraries which effectively can go and guess at types using other types. So it is possible now. It's not like trivial, but without having to manually insert the types yet, without having to manually insert the types, to get old code typed over time. Yeah.
Anyone else? You guys know? So
I guess one more question, if I may, to finish. So you seem to have a lot of Python internal knowledge as well in order to build Pydantic, and at least personally I found that it's easy to get started. It's easy enough to become intermediate developer, I think, but in order to understand the internals, I'm not really sure what path to follow to understand what's really happening under the hood whenever you execute whichever line. So maybe you can share your journey, or how do you think people should approach like this journey of becoming well aware of Python internals?
It's a really interesting question. It's something, I don't have a good answer to it exactly, because I can say what happened to me, but I'm not necessarily sure that's the most efficient route. I think the honest truth is back in 2017 when I started Pydantic, I did not have that much knowledge of internals. And that's probably some of the reason for some of the like corner cases or like nasty edges in Pydantic is my ignorance back then. But it's also one of the reasons I talked then about the like 30 seconds, 3 minutes, 300 hours. It has to work each for a project to get popular. And this idea of like empathy for your developers for the users of your library who don't know all the stuff you do. One of the reasons Pydantic is easy to get started with is when I started it, I didn't know much more. That's why I didn't use a decorator, I used inheritance, because it just seemed more obvious. And then basically I've had to learn internal stuff because people much more knowledgeable than me come and like create these issues where they smash my library and are like, you must do this thing. Sometimes nicely, sometimes not so nicely, and it like forces you to go and learn it. So the way I learn complex stuff is by trying and then being forced to learn more when I come to it. I'm not someone who like reads a textbook about how stuff works and then goes and implements something. I find it as I go along. I found like being at conferences, speaking to like core developers, listening to those conversations, it's frustrating that some of the most interesting talks at PyCon US, where you have all of the core developers, the language summit is not recorded, the typing summit is not recorded, which is a bit unfortunate in a way, because for me, those are the like single most interesting bits of those big conferences, because they like force you to understand it. But for example, Mark Shannon had a talk at PyCon this year, which will be recorded and will be on YouTube soon, about the faster CPython project and like the exact number of bytes that a class definition requires, what each of them does, and how he goes through them one by one and like removes them. So that would be that's a really fascinating, really deep dive into the like Python stack and how it works.
All right, thank you.
Cool. So thanks a lot again, and yeah, have a nice day.
Thank you so much.